Alright, so we have what's called the midpoint formula. Alright, the midpoint formula. If the coefficient of elasticity of demand is equal to quantity 2 minus quantity 1 divided by Q2 plus Q1 over 2. All of that. Price 2 minus price 1 divided by price 2 plus price 1 over 2. That is going to give you some number. The first thing you're going to do when you figure out the coefficient of elasticity of demand is you drop the negative, and then you have an answer that is either greater than 1, oops, I guess it didn't matter, but greater than 1, less than 1, or equal to 1. If it is greater than 1, the good is elastic or responsive. All right, if it is less than 1, it is inelastic. And if it's equal to 1, it is what we call a unit elastic. There's no real change. Yeah?
Can we get formula sheets right on the
No.
actual thing? No.
All right. So, there's another way that we can measure this. Oh, before I do that, there's also what we call perfectly inelastic and perfectly elastic. If it is perfectly inelastic, just remember the letter I, because it's inelastic. Perfectly inelastic looks like an I. It is totally vertical. Perfectly elastic looks like an E, or not quite finished E. It is completely horizontal. All right, the other way we can check for elasticity is what we call the total revenue test. Is this stuff sounding familiar? Bless somebody. All right. Total revenue. Is simply price times quantity. So price times quantity gives you your total revenue, and then what we figure out in terms of elasticity, is if total revenue moves in the same direction as price, then the good is inelastic. So for example, if your medicine goes from $5 a bottle to $500 a bottle, and your revenue goes from $10,000 to $500,000, you know it was inelastic. Price went up a lot, but people are still buying it. Okay? But if total revenue moves in the opposite direction of price, the good is elastic. So, the price of your hamburger goes from $2 to $1, so it goes down, but revenue goes from $10,000 to $20,000, revenue goes up, that meant it was elastic. People responded to the cut in price, they bought a lot more. On the other end, if your price went up, price went from 2 to 5, and your revenue went from $20,000 to $10,000, that meant they were responsive in the other way, all right? And keep in mind, guys, that as you look at as you consider like your demand curve, all right, part of the demand curve is going to be inelastic, some portion of it's going to be unit elastic, and some portion of it is going to be elastic. All right, every demand curve has portions of both, unless it is the vertical line or the horizontal. All right, and that was the last thing about total revenue too. If your total revenue doesn't change price changes, we have unit elastic. All right, that's just coefficient of elasticity of demand. Now let's do all the other elastic formulas. First up, there's no real formula that at least there is, but we're not going to go over it. The main thing you need to know about elasticity of supply is time lengths. All right, we have three different time lengths. We first have the market period. The market period is the immediate term. You are a tomato farmer, and your tomatoes are already loaded on the truck. You're driving to the city, and you hear tomato prices have crashed. There's not a lot you can do at that point in time. You've already grown all the tomatoes, so supply is inelastic at that point. All right? Short term can't do anything, or immediate term can't do anything. Short term, or short run, you can make changes to production but not to the plant. And when I say the plant, I'm not talking about the tomato plant. I'm talking about the size of your factory or your farm or whatever it is where you are producing things. Like, you can make some changes, like you hear tomato prices are going to go up. So you can fertilize your field a little bit more and hope that you get a better yield on your crop, all right? You can make that change, but you can't go back if it's already June and plant more tomatoes. It's already too late for that season, all right? So you can make changes to try to improve how much you put out that year, but you can't change everything. So in that case, you are somewhat inelastic, or you could say you're somewhat elastic. You have a little bit of ability to change, but not a lot. Long run, change everything or anything, and you are elastic. You can change whatever you need to for supply that year. You guys are finishing up over here. I'm moving back over here. All right. There's two other types of elasticity you need to know. First, you need to know cross elasticity of demand. Formula for this one: percentage change in quantity of X over percentage change price of Y. This is comparing two separate goods. How much of good X would you buy if the price of good Y changed? All right, the thing you need to remember for this one is you don't drop the negative, first of all. You're going to have a positive number, a zero, or a negative number. If you have a positive number, all right, then those goods are substitutes. Basically, what we're saying is, all right, this number is positive. We buy more of X when the price of Y goes up. Well, that means that price went up of that one thing. That means you're going to substitute it with something else. All right, if it's zero, it means they're unrelated. And if they're negative, it means they're complements. If the price of Y goes up and you buy less of X, that means if the price, so like if the price of hot dog buns goes up, then you're going to buy less of hot dogs. That means they're complements. They go together. The other one is income elasticity. That is percentage change quantity X over percentage change in income. Again, you're going to end up with positive or negative. Your positive number is going to represent a normal good. A negative number represents an inferior good. All right, we're getting close to the beginning of theory of the firm. Let's do utility real quick, because utility was kind of like that really short unit. Am I good over here to erase? Utility was that whole idea behind the shopping cart. Remember we did that activity where we went shopping and we had to decide what we were going to purchase. So we have, I'm going to bring this over here. Utility simply means want satisfying power. All right, if you buy something, you get utility from it. You don't buy stuff that doesn't give you any benefit. All right, you buy stuff because it gives you a little bit of something, something. All right, and it makes you feel. It makes you feel okay on the. All right, I'm gonna keep going, despite Billy's face in the back. All right, so there's a law of diminishing marginal utility. Basically what that states is as you consume additional units of a good or service, then the added satisfaction declines. Now note that that does not say that your satisfaction goes negative. It says that your added satisfaction declines. So like the first taco you eat at Taco Bell might give you 8 utils, all right? Because it tastes so good and you were really hungry and it gives you benefit. The second one might only give you 6. You're still a little bit hungry and it still tastes a little bit good. The 9th taco, all right, makes you feel sick, all right? And that's actually taking away from your utils, all right? And that's what it ends up looking like on the graph. All right, you've got utils over here, you've got quantity over here. Your total utility is going to look something like that. Your marginal utility is going to look like that. And where it goes negative is where the curve turns and starts coming back down. This is also utils and quantity. Okay. So your total utility simply stands for your total benefit. Marginal utility, additional benefit for each unit. There's one last thing. There is the utility maximizing rule. And this is part of that shopping exercise. All right. The utility maximizing rule says that the last items you purchase, your marginal utility per dollar should be equal. So remember, marginal utility is one thing. All right. If I bought the Mona Lisa, it would give me a lot of marginal utility. I'd have one of the most famous paintings in the world. It'd give me a huge benefit. It would also cost me hundreds of millions of dollars, which I don't have. So the marginal utility per dollar for me is negligible. My Mona Lisa on the wall cost $2 from posters.com. All right? Did it give me as much utils or as many utils as the real Mona Lisa? No. But for $2, it gave me more utils per dollar than the real one would have given me at 300 million or a billion or whatever it would cost. Okay? So we have to make our decisions not only based on the utility, but also based on the money we have to spend. And so the last item we spend, those numbers should be equal. If, for example, the marginal utility per dollar of a brownie is at $5, is at 5, and for a bagel, it's at 3, then we should buy another brownie, right? Because it's still higher than the other one. We should buy brownies up until the brownies equal 3, all right? So sometimes we'll end up buying 5 of one thing and 1 of the other, and that's okay, because the utility, the total utility is still maximized, all right? Don't forget, when we're doing these problems, you're tracking it based on marginal utility per dollar, but when it asks you for your total utility of your purchases, you gotta go back to the original utility figure, all right? It's not per dollar. If you bought, let's say, bread was 10, 8, 6, 4, and it costs $2, then our marginal utility per dollar is 5, 4, 3, 2. We have $4, all right? We would only purchase these 2, all right? But our total utility would be 18, all right? It would be probably easier if I added something else up here, wouldn't it? Do brownies again. So if the utility for brownies is 6, 4, 3, 2, and brownies cost $1, all right? Then we would buy a brownie, we would buy bread, and then we would have 3, so let's say we had $6. Then we would buy both of those, all right? But our total utility, at the end, we would have bought 2 brownies, that gives us 10. We would have bought 2 loaves of bread, but that gives us 18. Our total utility would be 28. We made our decisions based on the per dollar figure, but once we have them all, we get that total amount of utility from the purchase. Does that make sense, what I'm saying there? Okay. My notes are over there. All right, let's talk about costs. We'll get as far as we can. All right, first of all, we have economic costs. Those are all costs, both implicit and explicit. Our explicit costs are money costs. These are costs that you, business would actually have to pay money out to cover, all right? Your rent, your utilities, your paychecks for your employees, all those things are things that actually require dollars to come out of the company's bank account, all right? The implicit costs are simply a business's opportunity costs. So lost wages, lost rent, entrepreneurial ability. So if you start a business, and I forget who started the business in this class, was it Sophia? Yeah, so Sophia started a business, was a t-shirt shop in downtown Plymouth. So she started a t-shirt shop in downtown Plymouth, but she had to give up her other job. All right. Now, an accountant would look at that, would look at the numbers at the end of the year and say, did your revenue exceed your explicit costs? Did you make more money than you spent? All right. But she needs to take into account, is it really worth it for her to run a t-shirt shop if she's not taking care of the lost salary she had from her engineering job or whatever she was before? Does it make sense for her to not rent out the building she owns in downtown Plymouth and have her own shop there? And is she being compensated for her entrepreneurial ability? She took a huge risk. Is she being fairly compensated for it? And it is the compensation for these implicit costs, specifically entrepreneurial ability, that leads to our term that's called normal profit. That's an economic term. Did we cover all costs? Which is basically, it's kind of like economic costs here, but this is where we turn a profit as an economic firm. All right, you might have made money as an accounting firm or based on your accounting for the year, but did you make money taking care of you as a person too, as a business owner? All right, so, what else we got for costs here? All right, let's jump to our types of costs. So as a business, not only do we have implicit and explicit, we also have to account for our fixed costs and our variable costs. All right, so if we have a graph that looks like this, all right, these are costs, this are quantity. First, you have your total fixed cost. It doesn't matter if you make 0 units of your goods, you are going to have a fixed cost. Your rent, your insurance, your utilities, all those things. They are going to happen no matter what. All right? But if you have 0 units produced, your variable cost is going to be 0. All right? Your variable costs depend on how much you produce. So they start at 0, and then they go up. And then the total cost is the combination of the two. And the distance between them is your total fixed cost. Now, we typically have dealt more with the average costs, and the average costs are simply these numbers divided by quantity. All right, it tells us how much it costs us per unit. And that gives us an average total cost, average variable cost, average fixed cost. All right, on this graph, marker's starting to run out. Same thing, quantity, price, or cost. All right, an average fixed cost, because our fixed cost is going to be the same no matter what, but as we spread it out over more and more units of production, our fixed cost is going to fall, and it's going to get closer and closer to 0. Our average variable cost is going to fall, but then it's going to go up. And that is due to the law of diminishing returns. I'll try to, we skipped over it, so we'll have to cover that tomorrow. Our average total cost is going to fall and then start rising, and it's going to get closer and closer to ABC because the distance between these two is AFC, average fixed cost, and average fixed cost is going to get closer and closer to 0. So the distance between those will get closer and closer. And then there's one last curve to put on here. Our marginal cost curve is the Nike swoosh curve. And that is going to intersect, doesn't quite look like it on mine, but it's going to intersect ATC and ABC at their lowest points. And that's due to the law of averages. If the cost of the next unit is lower than ABC, then ABC is going to come down. If the cost of the next unit is higher than your average cost, then it's going to go up. All right, that's pretty much it for today. Was it helpful at all?
Yes.
Okay, so we've got the better part of the hour, if not the entire hour tomorrow, doing similar